Today I'd like to talk about a unit. This is a unit of energy, but it's a very special one that's used almost exclusively by atomic and nuclear physicists and chemists. It's called the electron volt, and it is the amount of energy which is added to an electron if you let it drop through 1 volt of electrical potential difference. It might seem like a strange way to define a unit of energy, but it turns out to be a very useful one. If we take a look at the spectrum of visible light, you'll see that this unit of energy varies as a small whole number across the spectrum. So it was very convenient in the early days of atomic physics, when the transitions of electrons between energy levels around the nucleus of an atom was of greatest interest. And it was more or less a matter of habit that it was continued into the era of nuclear energy, where extremely large numbers of electron volts are involved. For instance, a typical fission process releases 200 million electron volts of electricity. Now, we can speak of this unit of energy both in terms of the kinetic energy of a particle, an electron, and in terms of pure energy, the energies of photons of electromagnetic radiation. And that's why we say that visible light is from about 1 to 3 electron volts of energy carried by each photon. This diagram shows that the electromagnetic energy range is vast. You can see, if you look carefully, the tiny spectrum about 2/3 of the way up on the left side of this figure. And that's the only part of the energy spectrum that we can see. All the rest of it consists of things like radio signals, television, the signals that carry our voices over cell phones, infrared radiation, which we can sense. It feels like heat against our skin, although we can't see it. And ultraviolet radiation, which we also can't perceive directly, but which shows up as a burn on our skin a day later. And from there we go up into the X-ray range, where typically we're talking about from 10,000 to 100,000 electron volts, or from 10 to 100 keV. Above that, we go into the gamma ray range, where we start to get into MeV, millions of electron volts. And finally, we get up into the range of energies of cosmic rays, which are almost unbelievably powerful. So we need to use this energy unit in order to be able to talk about quantities of energy in what comes next. And what comes next will be nuclear reactors and nuclear bombs.